Hi, first thing I want to do is congratulate you on the majority of your homework was correct, and you absolutely did a great job with showing your work and seeing exactly how you did it, and I was really appreciative of that. But you did get a couple of them wrong, and let me just show you how to do those. The first thing I always tell my students is when you have a situation where you're dealing with similar triangles or even congruent triangles, the first thing you need to do is draw the two triangles side by side in the same orientation. Now, obviously, we see two triangles. There's this one right here, and then there's this one right here. So let me just kind of draw these in that way. And I've got the advantage of the computer, so let me just take advantage of that. Let's go like this. I'm just going to copy this guy, paste him over here, and then let's see, I'm going to take this one right here, so that way you know I'm not doing any trickery or anything. Copy this guy. Actually, I'm going to cut this guy. I'm going to paste him, and I'm going to rotate this guy thing. So let's rotate it 180 degrees. There we go. I know the numbers are upside down, but just kind of imagine taking this second triangle and rotating it. So now what you want to do is you want to do ratios. By the way, this is an x plus 6, not an x, or 9 plus x. X plus 6, not 9 plus x. And this is a 20. You're right, only because we rotated that thing upside down. But you've gotten so used to, I think the first 5 problems was dealing with congruent triangles, where these triangles were the exact same size, but they were different, or they had the different letters over here. And so you just said, okay, x plus 2 is equal to x plus 6. But you can't do that in here because we're not dealing with congruent triangles where they're the exact same size. We're dealing with obviously a smaller triangle and a bigger triangle. And the fact that they told you that all of the numbers in here are that these two triangles are similar means that all of the angles inside are the same. The reason why I like to orient them in the same way is because it helps me set up my fraction really well. I want to say that this side divided by that side is the same as this side divided by that side. Because it's not necessarily that the sides are the same, but rather the ratios are the same. So I can say something like 10 divided by 20 is equal to x plus 2 over x plus 6. Now, we can solve this out algebraically. Let's multiply both sides by 20. The whole point is to get rid of this 20 over here. And so on the numerator side, we can distribute that 20 in. And then we'll also multiply both sides by x plus 6, because x plus 6 is in the denominator here, and I don't like things in the denominator when I'm trying to solve for things. So I'm going to cancel out that and cancel out that, and I'll distribute this 10 into here, distribute this 20 into here. This becomes 10x plus 60 is equal to 20x plus 40. And then let's put the 40 on this side by subtracting it. So then you're left with 60 minus 40, which is 20. And then we'll put the 10 on this side by subtracting it. And so you're left with 20 minus 10, which is 10x. And divide both sides by 10, and you end up getting x is equal to 2. So a little bit off from your answer over here. This is the correct answer right here. And that is how you do that. I think that the biggest advantage you should do for yourself is to redraw the triangles, but put them side by side next to each other. That way you can kind of see. All right, let's try the next one. So this one you got wrong as well. And again, I think that the problem you had here was you didn't, first of all, you didn't label it correctly. And second of all, you didn't draw the picture side by side, because when you draw it side by side, it might become much easier for you to see. All right, let's see. MQ is 5. So that would be that, okay. QP is X. All right, we like that. All right, let's see. MN is 15 and NO is 2. Okay, cool. So let's draw these pictures side by side right next to each other. Oh, oops. I see two triangles. Granted, one is embedded in the other. I've got one triangle over here. Let's put this right here. And then I've got a smaller triangle we'll put it right here. I'm going to move over just a little bit. Then what I'm going to do is I'm going to delete this part off. There we go. And then over here, I'll just delete this line. All right, cool. So we know that this triangle, here's my two triangles. We know that this side is 15 and 2, so we'll just call it 17 if that's all right with you. And then this is x and 5, so we're going to call this 5 plus x. Now over here, we have 5 and 15, and that was the smaller triangle that was embedded in this bigger triangle. So now I can set up ratios. And first of all, they told me that they're similar triangles. But, and so that's all the information I need to just say, hey, they're similar triangles. If they didn't tell me they were similar triangles, I would first need to make sure that we're dealing with similar triangles. And in order to do that, I would need to make sure that all of the angles inside of the triangles are the same. Now, for this problem, I would say, okay, well, 5 plus x is to 5 what 17 is to 15. And then we just go through our calculator and see if we can solve this thing. So let's see. 15 times 5 plus x is equal to 17 times 5. Let me use my calculator. 85. And so I have 15 times 5. So I've got 75 plus 15x is equal to 85. And I've got 85 minus 75 is 10, obviously, 18. X is equal to 10, and I've got x is equal to 10 over 18. 10 divided by 18. It's 0.55555555, 0.55 with a line over it. All right, cool. Let me check that.